Hey all, so here's one more quick video for you here by popular demand. A few people had questions on number 29, the last one from the Wiley homework. And this problem is a little bit tricky, but what you'll see is once we get the concepts down, the solving of it becomes a lot simpler. So let's just think what we're told. So we're told in this problem statement that we have some sort of container. Alright, maybe it's a graduated cylinder, or, well, it's actually 1.6 meters tall, so it's probably not a graduated cylinder, but some very long, tall pipe. We'll act like it's a giant graduated cylinder or something. And it's filled all the way to the brim, so our fluids go all the way to the top, and we're given the total overall height, which I'll call H here, and it's filled with two different fluids. So it's got water in it, which takes up part of it, and then it also has mercury. So I'll just make the mercury green. Mercury is not normally green, but it is today. So you can think of the total height as being composed of a portion of the height that is the mercury and a portion of the height that is the water. So apparently my water is red since I already used blue for something else. I wouldn't recommend drinking red water, just so you know. Alright, so as you can see clearly from the image, the overall height is equal to the height of the water plus the height of the mercury. Okay, well that's fun and good, but it doesn't really help us solve, right? We're also told in our problem statement here that we're interested in, or we're trying to determine, what the ratio, or really what those two different heights are. I think we're asked specifically for the height or depth of the mercury, so it's this H sub m that we're trying to find, and we're told that the pressure at the location that we're looking at is going to be 2 times atmospheric pressure. Alright, so that's a value we can look up, and I think I gave it to you in the last video, but that's what we're trying to determine. So let's recall the basic principle that we learned last class, that the pressure at some depth, so some new pressure, is going to be equal to whatever our initial pressure is, so the pressure above or at the top of that depth, plus the density of our fluid multiplied by g, acceleration due to gravity, multiplied by h, the depth of the fluid. So in this case, we have two different fluids, right? So our pressure that we're trying to solve for, the final pressure at the bottom, we know to be equal to 2 times atmospheric pressure. And that's going to be equal to our initial pressure on top of our fluid is going to be atmospheric pressure, plus now we have two things contributing. We have our water, so we're going to have the density of water multiplied by g, which is a constant, multiplied by the depth of the water, plus the density of mercury multiplied by gravity multiplied by the depth of the water. So now we actually have an equation that becomes solvable. There's two unknowns in this equation. We don't know the depth of the water or the depth of the mercury. Oh, small typo here. That should be an M. Excuse me. I'll fix that really quick. That's the mercury. Okay. But we do have this relationship here, and we're given the overall height. So you should be able to solve for the depth of the water in our equation here and plug it in, and then be able to solve for the depth of the mercury. Now, there's a lot of things in here that aren't given, but you should be able to look up in the text or online and find what the density of water is, what the density of mercury is. G you should know, and you should be able to determine, look up again from the text, the notes, my previous video, or the internet, and find the atmospheric pressure as well. So go ahead, give that a shot, and let me know if you have questions.